thank you. We're here for the variable speed single-phase booster and circulator pumps and the upcoming changes that are going to be happening. So if we look at it, why energy efficiency and variable speed is our future. So U.S. electricity demand is growing. The commercial and residential usage is growing the fastest out of all the other industries. And what that looks like is, you have direct use, your residential use, industrial, transportation, commercial. But if you look at the graph in general, everything is going up tons, but residential over the time since 1950 has increased the most out of all the other industries. And if you think about it, we have electrical motors everywhere in our homes. Your HVAC system, your pumps, you name it, they're all in there. Now, the electricity generation, coal is actually declining compared to everything else. So solar, water, you name it, it's actually, all those are going up where coal is going down. And again, the largest sectors in the US are residential and commercial users. So, that's where all of our single phase BPM motor, PCS motors are. And again, if you look down here, there's all the electricity sales in 2022 for it. So there are quite a bit of benefits to the ECM motor, so the electronically commutated motors. If you look at energy efficiencies, you get about 80 to 85% peak efficiency on IE4 efficiency levels. And it maintains a lower efficiencies because it can run at a lower speed longer than on and off. So if you think about it, you're driving your car, you floor it, you let off. You floor it, you let off. Your gas mileage is not going to be good. But then again, if you look at it, you're maintaining a speed, you get 25% throttle, better gas mileage. The next thing that's great about ECM is they do have precise control, so the constant pump flow or pressure capability, so we can control exactly what it does through a computer. You don't have to worry about anything, it accurately controls speed or torque output at all times. Again, when you have a PCS motor or BPM motor, it's on or off. Can't really control it. Variable speed, it meets the needs for variable pump flow or pressure. Output is matched to system demand. So cooling towers, for example, you look at it, always going around, but if it's not needed, it's not going to run at such a high rate compared to everything else, which is very important for efficiencies and also cost savings for the end user. It's only run based on or upon demand too. So the customized motor output, it meets the needs, it limits inventory and model required as well. So why is that important? We don't need all of the different motors to slow things down and make things precise, whereas you have one motor doing everything for you. Lastly, it's a lot quieter. So running at a lower speed allows for the motor not to be as loud, having more comfort for the end user, which again is very, very important. So there's quite a bit of different types of variable speed pumps and fans that can impact the following major uses. So space heating, space cooling, water heating, ventilation. If you think about, again, inside your own home, you have a furnace, air handler, you name it. You have single stage, two stage, variable speed. More comfort on variable speed because again, it's maintaining that airflow throughout the home. Whereas if you look at a single stage, on or off again, not as good. So there are some additional incentives for variable speed pumping. The end user's comfort. Again, the control pump flow or pressure ensures the pump operates to a system requirements. So if it's not required at that moment, the pump's going to slow down. Low speed capability is quiet, efficient, and has constant flow. Again, another important thing inside your homes or buildings. And then the energy efficiency. The variable speed is much more efficient than any other of the PCS motors. Coming up, green initiatives. So today's world, commercial buildings use a lot of electricity. So being able to have a more efficient motor allows for a cheaper cost for all of our users and everything else. And then there is some regulatory influences happening. So ECM's increasingly prescribed in regulation. The circulator pump DOE rule is expected to come out in 2024 at some point. We don't have the exact date it's coming out, but we know it is coming. And it's increasing the efficiency standards will drive use of EC technology. And the requirements for variable speed for additional opportunity for EC. So again, we know it's coming. The rule is happening. Just don't know when, and we don't know the exacts to it. But again, ECM is probably the way to go to control all these types of motors on the fractional side. So, circular pump rule, what you need to know. So, establishing efficiency standards for circular pumps and small vertical inline pumps. The final rule is to be published early in 2024. The water-to-water efficiency standards. So, what is affected? Your wet rotor, your dry rotor, your three-piece circulator pumps with motor horsepower ratings up to 1 horsepower. small vertical inline stage, or single stage pumps with a shaft input power of up to 1 horsepower at its best efficiency point. So they're everywhere, and we know that they're going to go ahead and crack down on that, which is very important that we meet those standards. For the pumps to qualify, the DOE cannot force us on how to make the pumps, which is very important, but the DOE sets the wire-to-water and energy efficiency standards, which pumps must meet. Only high-efficiency circulators with ECMs will meet the standard for this. So we kind of know that so far going on, but again, ECMs is the only way we're going to be able to meet that. So the requirements of these products, manual speed control means a control variable speed drive and a user interface that adjusts the speed of the driver based on manual user input. Pressure control means a control variable speed drive and integrated logic that automatically adjusts speed of the driver in response to pressure. Temperature control means a control variable speed drive and integrated logic that automatically adjusts the speed of the driver continuously over the driver, operating speed range, and in response to temperature. Finally, external input signal control means a variable speed drive that adjusts the speed of the driver in response to an input signal from an external logic and/or user interface. So overall, all capable of testing at 25%, 50%, 75%, and 100% BEP flow. So due to the pump infinity laws, variable speed circulator pumps will achieve reduced power consumption at flow points less than BEP, by reducing their rotational speed to more closely match required system head. Now, what do you need to know about a variable speed booster pump? So, when we don't have it, we have all these additional things that are needed. And if you go directly to a variable speed with integrated drives, we can delete all the we can eliminate all the control panels, and the VFDs are on the motors. So it's more expensive to have it on a typical water system right now. And it also, again, it's easier to use. So, thank you. Any questions?